Okay, apologies. Hopefully you should see that now. So yeah, they'll answer them soon afterwards. You should receive a link to this recording of the webinar a couple of hours after it's finished. We'll try and edit that bit out. And if you wish to receive a copy of the slides, then please ask in the dialog box. So this morning's webinar is on safety first for warehouse automation, which is quite a varied and wide-ranging subject. However, we will be focusing today purely on machines that are within the warehouse environment as opposed to distribution. The agenda will be safety compliance for the OEM and end user, the standards that can be used to ensure compliance, an overview of the safeguards, looking at EN 14118, which is the prevention of unexpected startup, different types of applications and solutions within the warehouse automation, and then that should bring us to a close. The warehouse automation market is set to reach $27 billion by the end of 2025. And if you drive up and down the motorway network, then you will see large distribution centres and warehouse sheds being built at a rapid rate. Some are for clients and others will be speculative builds. These warehouse sheds will then be operated directly by the end user, be that fast-moving consumer goods or home health and beauty products manufacturers, or by third-party logistics companies on their own or in conjunction with their customer, i.e. the manufacturer of the goods. With the global COVID-19 pandemic and the disruption that has had on operations due to operators being told to stay at home or being off sick, the need and the desire to automate these operations and processes is ever increasing. However, because automation has still increased and human interaction has fallen, hazards still exist, or new hazards have been introduced when human interaction is required. UKCA marking. It is therefore more important than ever to ensure that human and machine interact smoothly and safely within the warehouse environment. So we're going to look at safety in the warehouse automation from both the original equipment manufacturer's perspective and then the end user's perspective. The two regulations that we have are the Supply Machinery Safety Regulations 2008, which is for the OEM, and then we have PUWER, which is for the end user and is the Provisions and Use of Work Equipment Regulations. So every OEM has a duty to make sure that their machine is compliant to apply a UKCA mark, and we'll go through that process in a bit more detail later. Whereas the end user must pure assess their machine once it's installed and put into first use. If you purchase a machine from overseas, for example, during the pure assessment, the end user may find that some of the safeguards, interlocks for instance, are not to standard. They could be easy to defeat, wide in series, etc. So who is responsible for UKCA marking? The responsibility for demonstrating that the machinery satisfies the essential health and safety requirements of the applicable regulation and can be UKCA marked rests on original equipment manufacturers and system integrators, agents that import machines, companies that directly import machines, persons who build machines for their own use, and persons who substantially modify machines beyond their original specification. It's important to know who is responsible for UKCA marking. As the end user, you may have imported the machine directly into the UK. So as the importer, you must ensure that the machine is in conformity with the principal elements of the safety objectives and that the obligations in the 2008 regulations have been met. The importer must ensure that the relevant conformity assessment has been carried out by the manufacturer and that the manufacturer has drawn up the technical documentation, affixed the UKCA mark to the equipment and drawn up the declaration of conformity. The importer must also keep a copy of the declaration and the technical documentation for a period of 10 years after it's been placed on the GB market. UKCA marking applies to most goods previously subject to CE marking. The technical requirements you must meet and the conformity assessment process and standards that can be used to demonstrate conformity are largely the same as they were for CE marking. The circumstances in which you can use self-declaration of conformity for UKCA marking are the same as for CE marking, and if you're able to self-declare conformity for CE marking, you'll be able to do so the same for UKCA marking. The process for UKCA marking is identical to what it was for CE marking. So you identify the UK regulations that are applicable that previously would have been EU directives. So in this case, we're looking at the Supply Machinery Safety Regulations. It could be the Electrical Equipment Safety Regulations, which was the Low Voltage Directive. We'd then determine the product-specific safety requirements from this legislation. We'd identify the UK designated standards, which reference the applicable UK legislation. Determine if you can perform self-assessment or if a third party is required. Test the product for conformity, either through self-assessment or a third party. Use results to create the technical construction file to show conformity. Create and sign a UK declaration of conformity. Cite the UK regulations and designated standards. And finally, place the UKCA mark on your machine. You must ensure that if you reduce or enlarge the size of your marking, the letters forming the UKCA marking must be in proportion to the version set out above. The UKCA marking is at least 5mm in height, unless a different minimum dimension is specified in the relevant legislation. The UKCA marking is easily visible, legible, and from the 1st of January 2023, it must be permanently attached. The UKCA marking can take different forms. For example, the colour does not have to be solid, as long as it remains visible, legible, and maintains the required proportions. Some key topics from the Supply Machinery Safety Regulations 2008. The regulations make it an offence for a reasonable person to supply machinery, partly completed machinery, or safety components unless they comply with the 2008 regulation. To comply with the regulations, machinery must satisfy the essential health and safety requirements which apply to it. The full list of EHSRs is laid out in Schedule 2, Part 1 of the 2008 regulations. The listings in Schedule 2, Part 1 of the regulations as amended begin with a crucially important statement of general principles. This in turn explicitly requires the carrying out of a risk assessment, meaning that the responsible person should determine which are the EHSRs applicable to their machine and in respect of which they must take measures. The essential health and safety requirements are mandatory. However, taking into account the state of the art, it may be possible to meet the objectives set by them. In the event, the machinery must, as far as possible, be designed and constructed with the purpose of approaching these objectives. The declaration of conformity and the technical documentation must be kept and be available for inspection by enforcement bodies, so the Health and Safety Executive, by the manufacturer if they're in the UK, their authorised representative if they're not in the UK, if neither of the above, the importer into the UK. They must be kept for a period of 10 years, beginning on the day on which the equipment is placed on the market. Manufacturers are able, by written mandate, to appoint authorised representatives to perform all or part of the obligations and formalities imposed on the manufacturers, either as manufacturers or responsible persons by the regulations. Mandated authorised representatives for the GB market cannot be based outside the UK after the 1st of January 2021. The manufacturer can only mandate an authorised representative established in the UK under the 2008 regulations as they apply in GB. It will also be possible to affix both the UKCA marking and the CE marking to the same product on the basis of self-declaration, where applicable, as long as the EU and GB requirements remain the same. However, you must remember when selling to the EU market, then CE marking remains mandatory. So I'll just briefly run through standards. So designated standards are made up of 3 types. Type A standards specify fundamental concepts, terminology and principles, of which there's only one, which is ISO 12100, safety of machinery, general principles for design, risk assessment and risk reduction. Type B standards are split into 2 categories. B1 deal with general machinery safety aspects, such as 13849, safety related parts of the control system. And B2 deal with specific protective devices or safeguards that can be used across a wide range of machines. So 14119 for interlocks, for example. And Type C standards contain specifications for a certain individual machine group. An example for warehouse automation would be EN 528 for rail-dependent storage and retrieval equipment. And if the C standard is followed in order, then presumption of conformity to the regulation can be assumed. It's worth pointing out that standards are not law, however, the regulation is. And the easiest way to show presumption of conformity to the supply machinery safety regulations is by following the standard. I'm not going to run through all the standards here, but some we're going to run through in a bit more detail will be 14118 for the prevention of unexpected startup. We'll look at 14119 for interlocking devices, 11161 integrated machine manufacturing systems. On C-type standards, we'll go into some detail on applications in 528, which is the rail-dependent storage and retrieval systems. So risk assessment and risk reduction to 12100. We'll go through the process. So we'd look at the limits of the machinery. We'd identify the hazards. We'd estimate the risks. We'd evaluate the risks. If those risks have been adequately reduced, we can stop the process. If not, then we have a risk reduction and protective measures that we can look at in a 3-stage approach in order. So we'd start with inherently safe design measures. So these are protective measures which either eliminates hazards or reduce the risk associated with hazards by changing the design or operation characteristics of the machine without the use of guards or protective devices. We'd then move on to safeguarding, which are protective measures using safeguards to protect persons from the hazards which cannot reasonably eliminated or risks which cannot be significantly reduced by inherently safe design. And then finally, we'd have information for use. And these are protective measures consisting of communication links. So text, words, signs, signals, symbols, etc. And used separately or in combination to convey information to the user. Safeguarding. So types of safeguarding. The safeguard is considered either a guard or a protective device. A guard is part of the machinery used specifically to provide protection by means of a physical barrier. And a protective device is a device other than a guard which reduces the risk either alone or in conjunction with a guard. So it's very common that a combination of both guarding and protective measures are used together. And in this instance, we have a robot cell with light curtains at the in and out feeds of the conveyors. We have a scanner that's protecting the open zone of the cell, and then we have an interlocked guard for access. 14118 unexpected startup. BN 14118 unexpected startup is very important when it comes to warehouse automation or machinery in general. If we take the same example from the previous slide, we could assume that the machine looks safe to operate. However, what if 2 or more people are working on the machine? An operator stops the machine and enters the danger zone via the access gate. Another operator then comes along, does not see their colleague in the danger zone, and starts the machine. And this we class as unexpected startup. In this instance, you may be able to see them through the guarding. However, in an automated storage and retrieval system that could be well over 100 meters long, or an integrated manufacturing system, this would most likely not be the case. It's worth considering that if you purchase the machine and it is UKCA or CE marked, when you come to assess it under PUWER as the end user, you may identify hazards not identified by the OEM of the machine, or the OEM may have interpreted the standards differently, enabling them to fit different types of safeguarding devices. And over the next couple of slides, I'll show you different safeguard solutions to prevent unexpected startup. So the majority of trap key manufacturers offer systems with a personnel key. And so if we look at the example here on the left-hand side, we have an isolation key. So if we turn the key that's in the key operated switch, that would stop the machine. That key is then taken to the key exchange device, where we can then release subsequent keys to gain access. So one is going to an access lock for part body access. So that may be that you just put in your arm in. And the other key is going to an access lock with a personnel key. So you insert the key, remove the personnel key, and you can then open the door. But what happens if there's more than one person? Generally, it then becomes a procedure based on releasing additional keys, or to use lockout, tag out with padlocks. Also, anyone can access the trap key system, whether they're trained and authorized to do so, or whether they're not. An alternative on the right-hand side is an RFID solution. The key is not left in the lock, it is defined with machine groups and operator permissions, therefore only allowing trained, competent and authorized operators to access. You insert your key into the reader, and if you are authorized, then you can request to access. After the machine has stopped, you release your key and open the interlock, taking the key with you. Once your task is finished, you close the door, insert your key, allowing the machine to restart. And I'll show an example of that now in the video. So our machine's running, the gate's locked, closed by the interlock. The operator inserts their key, it communicates to the controller to see if they're authorized. If they are, they can request to enter. When the machine is safe to do so, they can then unlock the interlock, remove the key and gain access. Now, whilst they're in there, nobody can come along and restart the machine. And when they finish their task, they close the door, reinsert their key and restart the machine. Where multiple personnel need to access the danger zone, a new technology that's been introduced is radar to performance level D, Cat 3, and this can also be used. So in this instance, the operator gains access through the interlocked gate. This activates the radar system. So if someone then tries to close the door behind them and restart the machine with the operator inside, the radar will detect them and prevent the machine from restarting. And again, we have a video that can demonstrate this. So this is our radar sensor. This is our robot cell. We can connect up to 6 sensors in series and feed them back to a functional safe controller. So in this instance, the operator is going up to the access lock. The machine's stopped, they've gone into the robot cell. Now an operator's come behind them, hasn't seen that they're in the danger area, closed the gate and tried to restart the machine. And at this point, the radar has detected that the person is still present and therefore hasn't started. Now no one's present within the danger zone, the machine can restart. Another RFID solution recently launched by PUWER is Key in Pocket. And this can be used for solenoid controlled interlocks, scanners, light curtains, radars, etc., up to performance level E. So in this example, there are multiple entry and exit points. The operator registers their key at the entry point, stops the machine and gains access. They can then leave at the same point of entry or any other access point, any other exit point, and in doing so, registers their key to tell the machine that they've left the danger area and the machine can be restarted. Multiple operators can register their key while in the danger zone, and only when all have left would the machine restart, making it ideal for expected startup for applications such as pallet wrappers and racking aisles, where there can often be more than one entry and exit point, and they can be also quite a distance from each other. And because the key is unique to the operator, you can also trace who has been on the machine or is still present on the machine. HMI security. So with the increase in automation, we need to look at machine safety in two ways. So firstly, machine safety, which is physical entry, so that's by doors and flaps, typically with interlocks to protect personnel. And then secondly, we need to look at industrial safety and security. So who can access the HMI and control system locally on the machine? How do they change operating modes of the machine from, say, automatic to manual mode? Are they trained, competent and authorized to do so? And how do we prevent remote access to the HMI and control systems? Historically, changes to machine operations and controls have been via passwords and mechanical keys, which though offer higher levels of reliability, the reality is that at best these types of technology offer low, if not any, level of safety, as they're either left in the panel in the case of key, or written down on post-it notes or inside the operating panel, for example, for passwords. And although technology such as fingerprint, iris, face recognition exists, the overall cost to implement is expensive. RFID technology offers a safety versus overall cost benefit, and its use is on the rise. So in this application, we're going to see access to the HMI. So the operator is walking up to the HMI, they're inserting their key, they're operator number 41, but they only have permission to read. Their colleague is coming along, they're inserting their key, they're number 56, and they now have permission to edit. The benefit of this is because it's on the key and the key is individual to the operator, you're less likely to hand the key over to a colleague to use it, because if that is found out, you can trace it back to who's the owner of the key, and then therefore, disciplinary action, etc., retraining could take place. So RFID technology for HMI gives personalized user identification, so password replacement. You can control or edit and read permissions, display of pages, switching of user language, for example. For the control or PLC, you can activate functions, you can toggle different variants, set recipes. With safe operating mode, access permission management for functional safe operating mode selection. Only authorized and qualified personnel can safely switch operating modes. And for door permissions, access permission management for industrial doors and gate systems. So only authorized personnel have access. Group and permission rights can also be set for each operator. So an example of this is coding. We have person A and person B, but in this example, only person A can activate machine A. We can have group-based right managements. So person G1 can operate both machines, but person G2 can only operate the machine on the right-hand side. You can set time limitations. So if you need to do retraining every 12 months, 18 months, you can set that on the key itself. So once that time has transpired, then the key would not be able to operate. You could also use it for contractors. So if contractors are coming on site to do work, you could issue them with a key that's only for the duration of their works. You can user define permissions. So person A can change language to German in this instance, person B to Italian. You can have a block list. So if a key is lost, you can block that key. So if it's found, it can't be used. Or alternatively, if you've found a key or a key's been lost, you can then also see who it was assigned to. And again, training, etc., could be given to that person as to why the key has been lost. And then also you have logging of all the actions. So every time a key is used, you can log that. And you have safe operating mode selection. So again, only trained, authorized and competent operators can safely change the operating mode of the machine. So an example of this, you can either do it with our PIP reader, an evaluation unit that can then go to any third-party fail-safe controller, or another option is that you can use the PIP reader in conjunction with one of our small safety control, functional safe controllers, or our automated PSS 4000 system. So the operator puts the key into the PIP reader. They will select a mode, and if the key and the evaluation unit agree that they match, then they can change that mode. And you can see that the service engineer, when they put their key in, they have different permissions, and in this instance, they're allowed to go to service mode. Applications. So ISO 11161, Safety of Machinery, Integrated Manufacturing Systems, which is a B-type standard. So I'll quote directly from the standard. An integrated manufacturing system is a group of machines working together in a coordinated manner, linked by a material handling system, interconnected by controls, i.e. IMS controls, for the purpose of manufacturing, treatment, movements of packaging or discrete parts of assemblies. An integrated manufacturing system can be very different in terms of size and complexity, and can incorporate different technologies that require diverse expertise and knowledge. An integrated manufacturing system should be considered to be a whole new and different machine rather than simply its parts combined. The integrator needs the cooperation of entities who individually know only a part of the whole. Where there are requirements for frequent manual interventions to parts of the IMS, e.g. for inspection, maintenance, setup, it can be impractical or unnecessary to stop the whole IMS. And ISO 11161 gives requirements to provide for the safety of individuals who perform these tasks and the use of what are called task zones. And a task zone, any predetermined space within and or around the IMS in which an operator can perform work. A safeguarded space is a space determined by the protective measures such that the hazards covered by these measures cannot be reached. Span of controls is a predetermined proportion of the IMS under control of a specific device. In this case, we have specifications of limits, which would be robot cells A and B. We have two either machine tools, they could be automatic racking systems. We then have a handling conveyor from left to right, which is connecting the two together. And we have the IMS as a whole. So we need to determine the tasks. So that could be task 1, tool change, task 2, cleaning. We then have access to task 1 and 2. So we identify the hazardous situations. From that, we can determine the task zones. So in this case, we've got zone 1 and zone 2. Followed by the safeguarding, including the span of controls. And in this case, what we have is we have a light curtain. For the operator, we have an interlock for access into zone 1 and also for into zone 2. An RFID key in pocket solution for interlock scanners, light curtains, etc. Is potentially a product that could be used in this example. So in this instance, we're using RFID keys to change the operating mode of the machine. And this could be automatic, setting, process, changeover, teaching, cleaning, maintenance, etc. And can only be done by the key holder who is authorized to do the tasks required. In section 8.10, start reset, part D, a means of preventing start restart shall be provided inside the safeguarded zone. Its operation shall override all safeguarding device resets and restart functions. In this instance, it can be done with an access permission and restart key, or scanners and radar as shown earlier in 14.118. AGVs are becoming ever more commonplace within the automated warehouse, and are either supplied as part of an overall IMS or added to it. Safe operations of AGVs is based on ISO 3691 Part 4, and in this example, the pallet is being fed via a conveyor onto the AGV. The dynamic navigation or inductive loop system will direct the AGV, but scanners or radar systems can be used to provide safeguarding and feedback on people or hazards along its route. The example here shows two AGVs, one with front and rear detection and the other with 360-degree detection. Both examples are using two scanners, front and rear, with two zones, one to reduce the speed or the change direction in yellow, and the other to stop the AGV in red. Both linked via a functional safe controller outputting to the drives of the AGV. So this is our AGV with the scanners installed. Here is our area that we're looking at, our two zones for warning and stopping. In this case, the robot is loading up the AGV. It's now moving along its predetermined preset path. It sees an operator in the way, so it will move to the right to go around it, to go around him. It then goes back to its navigation point, and now it's coming up to another operator, but it can't move left or right because of the racking and the alleyway. So in this case, it comes to a stop. So from the previous slide of the IMS example, it may be that the operation station is replaced at a later date by an AGV. AGVs often form part of an AGV system in combination with other AGVs, machines and storage systems. The AGV OEM is only responsible for the safety of the hazards that can be foreseen. The OEM of the original AGV is not always aware about new hazards which are created when the AGV are combined or interfaces towards other conveyor or load handling equipment. In order to make sure that those hazards are considered and handled appropriately, the supply machinery safety regulations state that an assembly of machines must be considered as a machine which must fulfill all the requirements of the regulation. And responsibility must therefore be assigned for the complete AGV system assembly, which may include the need for an additional UKCA marking of the AGV system. OEM, integrator, and the end user are typically all involved in an AGV project, but it's important to know that only one can be the manufacturer of the AGV system in this case. So if you're an end user and you're doing an AGV application, an upgrade, then at this point it's worth finding out and knowing who exactly is going to be responsible for the overall project, so that later on down the line there are no issues. The concept of UKCA marking and assembly of machines is unique to the supply machinery safety regulations. In this respect, UKCA marking of an assembly is different to UKCA marking of an individual unit. As AGVs are often integrated into existing machines or systems, this may be a grey area as there is no clear criteria but only direction. Adding or replacing an existing with a UKCA marked machine that does not significantly affect the operation of the assembly, and no action is required. However, adding or replacing an existing with a UKCA marked machine that significantly affects the operation of the assembly, then new UKCA marking of the assembly or part of the assembly affected is required. EN 528 rail dependent storage and retrieval equipment. The use of automated storage and retrieval systems has grown dramatically over the last few years, coming from the demand of online retail and the need to reduce operating costs. However, there is still interaction between human and machine, and as a result, hazards still exist. EN 528 give OEMs and end users all the information they require to comply to the supply machinery safety regulations. And over the next couple of slides, I will discuss how operatives can operate them safely. EN 528 talks about mode selection and prevention of unauthorized access. In section 4.3.3, prevention of unauthorized access, that's an equipment switch. In 4.3.4, changing mode of operation, a mode switch. And in 3.3.5, key dependence, the same key as 4.3.3 and 4.3.4, which we'll go through. So in this example, we have our automated storage and retrieval system. All the access doors are closed and the automatic storage and retrieval system is operating. Remove key from position 1, put in the ASRA into manual mode. This key is then used to gain access through the interlock door at position 2. And then when inside, you can insert the key into the mode switch at position 3 on the storage retrieval machine to change the mode. A way of doing this is with the trap key technology. So you have an external mode selection switch, where when you turn and release the key, that will change the mode of the automatic storage and retrieval system. That key is then inserted into the access lock, and then it can be inserted onto a key onto the storage retrieval machine to change the mode. An alternative way is with RFID keys. So for automatic machines, under normal conditions, the automatic storage and retrieval system is operating. If the ASRS then needs to be operated in manual mode, the RFID key is removed from the outside switch. So all power motion shall cease and the storage retrieval machine shall remain stationary. The storage retrieval machine is therefore in manual or off position. The RFID key is then inserted into the access permission reader. Request to enter light will illuminate. You remove the RFID key, which allows the door interlock to be opened. The RFID key is then inserted into the switch which is mounted to the onboard control panel of the storage retrieval machine, putting it into manual mode and allowing the operator to take control of the machine for could be commissioning, fault finding, etc. And to put the automatic storage and retrieval system back into automatic mode, you would reverse the sequence. For manual machines, under normal conditions, the ASRS is running and the RFID key is in the access lock and the machine is in automatic operation. You'd request to enter. When the ASRS is ready, a light will illuminate. You remove the RFID key, which allows the door interlock to be opened. The RFID key is then inserted into the switch, which is mounted on board the control panel of the storage retrieval machine, which allows the operator to take control of the machine. And again, to put back into automatic mode, you would reverse the sequence. In this application, we're looking at a robotic palletiser. We have two sets of light curtains at the in and out feed, complying to EN 61496 Part 1 and installed to ISO 13855. along with an access lock with access permission. The robot is stopped if either light curtain is broken by anything other than the loaded pallet, or when an authorized permission key is used to request access. So you have the use of either trap key technology for access with personnel key, or an alternative is RFID solution with key in pocket to prevent unexpected startup by only authorized and competent personnel. And finally, end-of-line packaging. So in this example, we have a pallet wrapping machine with a number of previously discussed products on it. An unwrapped pallet with packed products on it will make its way to the start of the pallet wrapper via an in-feed conveyor. At the entrance, we have a set of light curtains and a muting sensor, which have been set up to determine if it's a pallet heading towards the light curtain. If it is, then the light curtain will temporarily mute, and the muting lamp above the light curtain will illuminate to warn personnel the light curtain is muted. If it was a person to go along the conveyor for any reason, then they wouldn't break the muting sensor correctly, and the light curtain would still be active and stop the machine. We then have an interlocked guard on the side of the machine, which needs to be closed to run the machine. However, it may be necessary to run the machine at low speeds with the guard open, so that certain operations can be conducted, such as setup, maintenance, etc. And this may be done via a two-hand control or a jog enabling switch, which prevents the operator, coming into contact with any moving parts. But you only want authorized and trained personnel to carry out this task. So to do that, you would do that with the use of RFID keys, and in this instance, our PIP mode device. So if you don't have the correct RFID key, you can't carry out the task. And so by selecting modes of operation, we can therefore make defeating the interlock unnecessary or unattractive to the operator. So that's brought us to a close to this morning's webinar. I'd like to thank you all for attending this morning. All future webinars can be found at our exhibition events page on the link provided here. We're actually exhibiting next week on Tuesday and Wednesday, the 29th and 30th of March at Intralogistics, which is at the CBS Arena in Coventry. You'd be more than welcome to come onto the stand and talk about any issues, applications that you may have with us face to face. If you can't make that event, then we're also at the Drive to Controls exhibition on the 5th, 6th and 7th of April at the NEC in Birmingham. And just to make a note that all our previous webinars can be found at our go-to stage page. And again, the link's provided there. So I'll leave the webinar open for a brief while, just in case there's any questions that are being answered in the background. Thank you very much for attending and have a great weekend.